It's Tanzu Tuesdays with your host, Robert Burley.
All right, welcome to Tanzu Tuesday, everybody. Hello, pew pew pew. Woo! I haven't done the noises in a while. It felt like it needed to come back, so I'm glad.
Yeah,
it was time, right? I felt
we've really missed your mouth noises.
Said no one ever. Welcome to Tanzu Tuesday. So excited to be back hosting with my friends Tiffany and Paul. Hello, welcome. Good to see you.
Did you miss us?
I always. This pandemic has hurt a lot of people, and my social life has gone way down. And seeing my work friends is a big bummer. I miss you all.
I've never even seen you.
You've never seen me live, and that's the biggest tragedy of it all. We should have been to 100 shows together by now. So yeah, they're all virtual, which is great. I'm glad we're able to do something, but I do miss the personals. And speaking of missing the personals, our next guest is a regular at the Spring One Tour. And so someone I really enjoy hanging out with post-show and grabbing some food and having a good conversation with. He's coming to us from the lovely state of Utah. Please put your hands together and welcome Josh Cummings, everybody.
Hey, everybody.
Happy to have you here. How are you?
Thanks for having me. Doing just great. Weather's lovely in Utah. We got snow, we got real snow this weekend. So That was super nice.
Not like the dusting kind of the first little...
Not like it melts within 5 seconds. Yeah, it doesn't stick to the ground. Yeah, this actually, I mean, this time of year, it still only stays for a couple of days, right? But but still, it's enough for the kids to face plant into it and do a snow angel or something. So yeah, pretty fun.
Yeah, we're still waiting for. We've had a couple specks of rain, but we're still really waiting for that rain, which is hopefully coming later this week. So
that'd be cool.
We're still in our late spring, fall.
Man, it rains enough here.
Very late spring.
I don't look forward to the rain. I'm not when's the rain coming? I'm snow.
Yeah,
it doesn't snow that much in Seattle, though, does it?
No, that's the problem.
Right.
It is fun when the roads ice up and you see all the videos of the people sliding down the road.
Doing 360s.
Yeah, right. Yeah, we obviously in California are always in some sort of state of just getting over a drought or about to go into another drought. So anytime it rains is a great and wonderful time.
Yeah.
So anyway, so Josh, we're so happy to have you. We're going to be talking some OAuth stuff, talking security. You are the Spring person. That's why we have you on this show, but also why we love having you on the Spring One Tour show. Adding that perspective, security is, of course, such a huge conversation that any enterprise people are it's one of the top things that they think about. And so it'd be nice to hear your thoughts, and can't wait to get to your presentation. Before we do that, of course, we're going to have a few announcements. Next week, if you haven't registered for Spring One Tour, go to springonetour.io and register for the November 18th and 19th. It's going to be Bella Bai and Alexei Nestorov. Josh, you friends with these people?
With Bella? Sure, yeah, I know Bella.
Yeah, Bella and Alexei, and they're going to be doing testing. So particularly the testing trophy, focusing on the high-level integration tests and introducing static analysis as the base. And so that'll be a lot of fun. It's a 2-day event starting 9 a.m. Pacific both days. First day is 2 hours where Bella and Alexei will be sharing and talking, and then the second day will be a good Q&A where we'll have the audience, you have a chance to ask questions to what they were presenting. But you have to register if you want to be able to do those questions. If you don't want to register, you still want to watch, you're more than welcome to watch it at our Twitch channel that you're on right now. We will be live streaming it, but you just won't be able to get any questions answered. And sometimes that'll just drive you crazy not knowing the answer. So I recommend registering, again, springonetour.io. Also next week, November 17th through the 20th, I'm wearing this in honor of it. This was last year's KubeCon from San Diego. And so this, of course, is a virtual KubeCon, the North American version. And that'll be, again, November 17th through the 20th. Go to events.linuxfoundation.org, and you can register for all the wonderful KubeCon Kubernetes activities. Kate's. Is Kubernetes is a thing even? I mean, I thought, is that even still a thing? Okay. And of course, always go to tanzu.tv. You can check out all of our different content that we have. Clearly, Tanzu Tuesday, our catalog from that. And then we've got our daily show with Kote, who's really upping his game and making his content awesome to both look at and listen to. And on Mondays, we have Between the Chair and the Keyboard with Nate Shuda. Wednesdays, tomorrow is our code, where we have a Spring Advocate coding. Usually, so last week was Josh, right?
Yeah, I think it's Mario this week.
Mario. Okay, so Mario tomorrow, and that's at 12 p.m. Pacific.
That sounds right.
But again, go to tanzu.tv and you can check out all of our channel timings. And also 2 weeks ago, Paul and Tiffany, you both hosted TGIK, which we live stream on Fridays on this channel as well. That's and right. It like crushed. You guys have like 1,400 views already, which is so great. So go check out TGIK either through our channel or on YouTube, TGIK, and search the one with Paul and Tiffany from like 2 weeks ago. And make sure you add that to your watch list. Did I miss anything?
I think you got it all.
Good. All right. I'm welcoming everybody to chat. If you have any questions during this, please make sure you send that out and we'll ask Josh at the appropriate time.
Oh, you know what you did miss out?
What did I do? What did I miss?
You were supposed to remind folks to like and subscribe to our Twitch channel. Like and subscribe. You can't just like it. You got to subscribe to it. That's how we know. It's all static, statistics, numbers. Okay, everybody, we need to know. That's so right. Please, yes. Bob actually gets paid on the number of eyeballs, but they pay him for every second eyeball. Yeah. So it was a bad sign on my point. I should have consulted somebody before making that choice. But you need to job security. You need to get better OKRs. Exactly.
There's also a difference between subscribing and following.
Oh, I don't know. It's just words you say.
Following, like you actually follow and see when things come up. Subscribing usually involves the moolahs. Yeah, I think those are the YouTube terms anyway. I think in Twitch you're supposed to fave. I don't know. No, there's different in Twitch. Oh, really? I don't know. We should know this stuff. Do whatever it is that involves you following our channel and watching our stuff. Okay, thanks. Yeah, don't pay money. Just click buttons so you get notifications. Oh, I was going to say you could just start sending me checks. Skip the middleman and start sending me money directly. You can join Bob's Patreon on patreon.com/theRobertBrindley. That's right. The She Shed doesn't pay for itself. Do you actually have a Patreon? No, I don't. I actually have one in his name, and I do very well. Thank you very much. Oh, I'd love to see your birthday shout-outs. That one Soroder got for his wife from Napoleon Dynamite was incredible. I don't know if you saw that on the socials. He posted it. It was incredible. Shout out to Richard Schroeder. Hope you're doing well. He got, I can't remember the actor's name. But anyway, Jason Heder. Anyway, the actor who played Napoleon Dynamite, he did like a 2-minute happy birthday thing to Richard's wife. And it was great. It was like, I was really, really like impressed with the amount that he gave as a performer. You know what I mean? Right. Like you think they'd just like phone it in or be like, whatever. He committed, he did it. He ad-libbed and it was 2 minutes. It was really great. So anyway. Wow. And to be fair, he did actually phone it in. It's true. It was on his phone. Look at you. Yeah. Look at you. You're already getting a shout out for your Four Seasons background. Thank you. So let's bring Josh in. Unmute yourself, sir. We want to talk to you now. Thank you for letting us get that out of our system. You guys are a joy to listen to. So, yeah, you've got 7 children, so you're not got to know when to be quiet. This is like dinner all the time. Yeah, 7. So do you have like a 9-person like dining table somehow? Yeah, we do actually. Yeah, we have this big. Well, so one of our kids is a COVID baby. He was born in April during the shutdown, which was a lot of fun. Wow. Yeah. Right. Wow. That was congratulations. A different experience. Thank you very much. And so he's not eating at the table right now, and we've joked with our oldest son that he needs to leave the house by the time this little one needs a seat at the table. Otherwise, he's going to be like making the 2-year-old sit on the floor. So, and your oldest son is 38, right?
Time to get out, son.
Yep, time to get out.
Yeah. This is why we had this other kid to like just push you out of the door.
Exactly. Don't make us have another one because we will. Because we know how to, obviously.
Obviously, we're very productive.
Well, congratulations. Yeah, what a weird time to have a baby, just in terms of all the, the
For
6
sure.
other times, going to the
So many
hospitals.
people are having babies right now. It's popping up all over my Facebook, and I'm like, oh my gosh, so many COVID babies.
Well, first of all, welcome to 30.
Oh yeah, that's true. That is the age where all your friends have babies.
Your friends
Are
are
you
now
talking to
going to
me?
be. Yes, of
I'm
course.
not 30 yet.
She's 29
Saturday.
and
You're
11
closer-
months and
You're closer to
23
30
days.
than you are 29.
Yeah, but you have to wait until next Saturday.
Okay. Anyway, so yes, welcome to 30. A lot of your friends are going to start having kids now. And that's what Facebook and whatever social media that you turn to.
Well, lots of friends are having kids a few years ago. It's just like right now during COVID, I have seen the most number of people having babies than at any other point in time, except for like 3 or 4 years ago.
Look, Tiffany, we've all been in lockdown for nearly 10 months now, and there's only so many things you can do at home other than play Scrabble.
And grow out your beard to become lamb chops, which Paul did. So Josh, let's talk about you in Spring, and in particular, kind of how you came into, getting on the team and, your trajectory.
Okay. Yeah. So I've been a software engineer for like forever, since perhaps before Tiffany was born. I'm not quite there, but yeah, I started developing in 1999 and started using Spring. Oh gosh, like a long time ago. Started using Spring in like 2004, somewhere in that neighborhood, and I've just used it ever since. Started moving into application security, not because of Spring, but I ran into this, what's called an intentionally vulnerable web application, which basically means a web app that on purpose has a whole bunch of security bugs to help you learn about, like, they call it ethical hacking these days, but how to learn how to do that kind of stuff. And was fascinated by it, started learning about security, got way into Spring security for many years. And yeah, eventually started contributing, and I've been full-time for almost 3 years. It's in 3 years in February of 21. And yeah, it's a real pleasure working with Rob and Joe and Rhea. It's a great team, and the community's great. And yeah, right now we're working on lots of OAuth support, SAML support, and all of that's super duper exciting. We see lots of people using it, lots of people benefiting from it, especially from like hopefully they help you to make the right security decision, because a lot of those frameworks are pretty complicated and it's hard to know what the right choice is. So yeah, that's what I'm doing these days, and it's a blast.
All right, quick question on the OAuth. Was there an OAuth 1?
Yeah, there was. Yeah. A long time ago, there was an OAuth 1, and then there were some pretty serious issues, and so there was an OAuth 1A that was released, and OAuth 1A was supported for a while. And yeah, OAuth 2 came out in, believe it or not, OAuth 2 was ratified in 2012. So it's quite an old, like as far as software engineering goes, it's quite an older spec these days. But yeah, not many people still support OAuth 1A. I haven't run into it for a long time myself, but yeah, there was an OAuth 1.
It's one of those things I've always been curious, but not quite curious enough to actually Google it.
Nice. That's what I'm here for. All the stuff that you don't want to Google.
All right, cool. Well, one last thing I don't want to Google. Does OAuth build on top of OIDC, or is OIDC
it's the other way around? It's the other way around. Yeah. So you can think about OAuth as like the key to your car. And so it doesn't matter who has the key, your car still starts, right? That analogy doesn't work as well in 2020 as it did in 2012, but because now there are really smart keys out there, I guess. But authorization doesn't care who you are. However, slowly people started saying, well, I know that OAuth is not meant for authentication, But man, it's still really useful to look at that token and figure out who the user is and get them logged in and blah, blah, blah. And people started doing it anyway with like Facebook and Google. Like you could use Facebook, like ask for the email address and then create an account on this other third-party application side or whatever. So enough of that started happening that folks said, well, we need another spec to standardize all of that. And that's what OIDC is. So OIDC is the authentication layer over the top of OAuth.
Gotcha.
Yeah.
So authorization versus authentication.
Yep.
Okay, cool. And is that the whole auth N versus auth Z thing, or is that something else again?
Yeah, no, it's the same thing. Yeah, so if you hear people say auth Z, that's referring to, can you do this? Are you allowed? And auth N is referring to, who are you? And sometimes a lot of times you can answer one without the other. You can know if somebody's authorized without knowing who they are, just like you could have a car key and not know who's holding the car key. So long as they have the car key, they can start the car.
Cool.
I just push a button now on my car.
I know, right? Or you just like start walking out and like there's like this, like your phone like starts talking to the car and says, hey, start, right? Yeah, it's pretty amazing. Yeah.
Yeah, the latest thing my phone has been doing is like telling me how far away this thing is when I like sit in the car and I'm like, you don't know I'm going there. Don't tell me how to get home in 12 minutes. I mean,
That's
I'm going
funny.
home, but don't tell me that.
Also, we probably shouldn't be talking too much about cars right now. They might still be a sore topic for poor Tiffany.
Still don't have a car. Me.
Oh boy.
Yeah.
What happened? Did you get in a wreck or something? Or
A certain someone I know, not here, forgot the e-brake, and the car was a manual car and it was in neutral, and like 5 to 8 minutes after getting the house, the car rolled down the driveway and smashed into my car and totaled it.
Oh my heavens. I'm
And
so sorry.
The other car is a little bit of denting. Like teeny little bumper denting. So I have no more car as of a few weeks ago.
The car is deed.
But on the upside, you have something you can hold over somebody's head for a very long time.
True. Especially since I still don't have the money from it yet.
Right. Oh, right. Which you're then going to pay your taxes with.
I didn't know that I still had stock in that account. I thought Amazon moved it, damn it.
Wah, wah, wah.
And my $751 bill just for checking out what's wrong with my sinus a couple weeks ago.
The trials and tribulations of being Tiffany.
Or
so we could have a whole podcast about it.
This is actually the sort of thing that happens when you turn 30. Is like, you know, you've had the chance to like be an adult, but at 30, like adulthood is forced upon you.
Yeah, now it's like no more jokes. It's time for reals.
Oh, money, bye.
Bye-bye. You weren't going to use it anyway. It was just sitting there. All right. So I think we've already, Paul, those were some excellent primer questions to get us going into our conversation. So we even have one of how this differs from WebAuth N. So it's already happening. It's all happening naturally, which is great. So with that, I think we will stop talking and we will allow Josh to present. If you have any questions, please put them in the chat and we will get to them when we can. And away, Josh, go.
Should we actually quickly answer that question?
Yeah, I was going to say, that's a question.
Twitch?
Yeah,
unless you're going to answer it through the talk.
No, we won't. No, I won't.
VRS Sun 84 says how this differs from WebAuth N.
Good question. Good question. Yeah, so there are lots of authentication mechanisms out there, and WebAuth N is like using the fob that you can plug into your computer, for example, and it allows your browser to interface with hardware in order to authenticate you. Whereas OAuth is a little bit more so I should say that OAuth could potentially use WebAuth N as well, because the point of OAuth is just to get a token that then can be distributed throughout like a distributed system. But anyway, WebAuth N is an authentication mechanism and OAuth is an authorization mechanism. Once you have the token, then that token is a statement of authority on what you can or cannot do with various and sundry REST APIs or microservices in your system. So that's the difference. That's the difference. We're not talking precisely about authentication mechanisms today. We will have to get authenticated to use the application, but we are mostly talking about authorization today. Hopefully that answers the question. And you can kind of see, you can get a little bit of a hint from it. WebAuth has, so Paul asked this earlier, he said WebAuth versus, or auth versus auth. Auth refers to authentication, figuring out who the user is. And then things like OAuth are about figuring out what they are allowed to do. Great question. Are there other questions or should I just jump in?
Go ahead and jump in.
Sweet. We will do that. All right. Great first question. Informed audience. All right. So I have just a couple of slides. I have the obligatory who am I slide and the obligatory here's how you contact me slide. And then that's it. The rest is just coding. So hopefully, sorry, I'm looking for the thing at the same time. Hopefully the code is still illustrative. Anyway, today we're talking about application security, right? Like I never ever talk about this. It's a real shocker. Actually, I always talk about it and it keeps me from getting invited to dinner parties. I talk about it so much. So we'll talk about it today and we're going to focus on single page applications, browser-based applications, and how that's different from other apps that use Spring Security, and how Spring Security helps with cores, with Csurf, with OAuth, as Paul asked about earlier, and how that can make our front-end applications, how they can simplify them while still keeping them nice and secure. A little bit about me. I'm a maintainer on the Spring Security team. I've been doing that for about 3 years. And it's a real joy. I have 7 beautiful children and I love frosted mini wheats. So if we ever get to be in person again, we can all have a cereal summit together and I will pick the mini wheats. And that's it. So let's head into the code and into the application. I want to show you what we're going to build. First, I'm going to show you what we will build, and then we'll build it. So this is a finished product. You'll be totally shocked at the UI. It's really breathtaking. So if I log in as my favorite person, then we see kind of like this very typical consent screen that we're all kind of used to these days. A consent screen doesn't always show up when we authenticate, but it's something that everybody has probably seen, like with Facebook or Google or something like that, LinkedIn, that says that this other third-party app wants to use data that is being that is housed over in Facebook or Google or something like that. Are you okay with that? So we say we're okay, and then we get this widget. And I'm actually really excited about this widget because check it out. I'm not a UI guy, so this took me a bit to figure out, but this is really cool. See, look, and this didn't take any JavaScript, it's just pure CSS. Like, do you see how it gets smaller and bigger? I'm sure that UI guys are like, that's really normal, but for me, that was really significant, so I'm super excited about it. But anyway, it's a simple UI that just allows you to take a counter and press it up and down, and that's just enough from the front end to be able to see some really important security implications for how this application interfaces with a REST API that's going to hold on to this data and take care of it for us. The other thing that you can do with this app is you can, if we log in as Bob again, you see that there's a choice here, right? There are check boxes here that you can check. And so let's say that Bob, for one reason or another, doesn't want this application to have write access. Like, it's asking for both. It's saying, hey, can I read and can I write this data? And if Bob says no, then hey, no problem. We can still function and gracefully degrade in our application and not show any, or not give any write access to this application, and it still works just fine. So let's go ahead and start building it. I have this in a Git repo. Actually, let me jump over there quick. If you want to check it out afterwards, there's a link that I have in the final slide as well. But it's called Spring Security Tanzu Tuesday, November. And feel free to take a look at the commits. Anything that we don't quite get to today, you can check it out here. and play around with it, give me feedback, and continue asking great questions like what we started with. So let's go ahead and check out. Let's see here. We might have to go grab the mouse. My right click just stopped working. But for now, we can do it like this. One moment.
Tiffany's still here if you need us to like have her sing a song while you go get the other mouse, by the way.
If Tiffany can go run and get my mouse. Oh, okay, that's a good idea. I will do that. That will help because doing here from the command line is going to take much longer. 1 second.
No problem. Hello, is it me you're looking for?
Yes, it is.
I can see it in the smoke in your background. There's a fire made from tires. Don't wear a mask, just inhale it because it'll make it go faster. That's what I got. That's it.
Thank God he's back.
He could not have returned fast enough. Whew. Josh, it was starting to really go downhill. I think we lost all but one viewer, and that includes Tiffany. She's not even on anymore.
That's hilarious.
No, it's all right.
Cool. All right. So now, well, it's funny because apparently the right click on my little trackpad is not working. On my desk, I use this like incredibly huge mouse. And so anyway, now it's precariously balanced on my laptop, but it's not a problem. Okay, cool. So what we've done is I've checked out to the initial revision before we built anything. So let's go ahead and start building stuff. I'm a command line kind of guy. So we could do start.spring.io, but I'll just use the command line, and we're going to use a newer boot version because there is a very cool feature in Spring Security. If you have used Spring Security for any amount of time, that you'll see a marked difference in the way that you can create or you can interface with Spring Security. So I'm super excited about that. So let's go ahead and unzip, and we'll go ahead and override anything that it needs to. And now we have a simple REST API. I haven't included any security yet. That's on purpose because I like to show the difference between what happens with security and what happens without it. Go ahead and change this to a YAML file just because that's sort of my preference. And we'll do one little housekeeping item and change the port here, because what we're going to do is we're going to create 3 applications. This app is going to be on 8180, and then these other 2 will be on 8280 and 8080. So we'll just change it now so we don't have to remember to do that. Okay, cool. Let me close some things up so you can see the code better. All right. So first things first, let's go ahead and create a resource. If we want to create an application that's going to interface with some kind of data, and that data is going to be that little counter that you can move up and down, I'll go ahead and create the value, and then maybe we'll also have like the owner of that data, and then we can go ahead and create a constructor, and let's create some getters for each one of these. And we'll change this guy. I'm going to have it be an atomic integer because today, just to keep things a little quicker, I'm not going to back this with a database or anything like that. It's just going to be in like a concurrent map. So let's go ahead and create our up. That allows us to increment the value. And then we'll create a down. That allows us to decrement the value. Okay, pretty simple stuff. We'll go ahead and create a controller to allow us to manage this. And then I've got a little bit of just get rid of a little bit of boilerplate there. You'll see that we're going to use a concurrent hash map to keep track of it. It's going to use as this endpoint sentiment. And then we can return the value when it's read. We'll need to, because we're going to have this keep track of it by user, since we haven't added security just yet, we'll go ahead and give a default value here. And then return the value that we look up on the map. And if it's not existing yet, then we'll go ahead and create a default one that has like the value 0 set in it in the beginning. Let's go ahead and add our posts. So the first post we'll say is up. And then the second post, we'll go ahead and call it down. And then it looks pretty good. We should be able to use this API to keep track of this value for each user. Let's go ahead and give this a default value though, and then give it a whirl. In fact, I think because of the demo, I had the other ones running. So let's go ahead and stop those so we don't have any noise. Then we'll pop over here and just check it out, see how it works. Oops. Okay, great. So we were able to get the value back. And if we go ahead and post, we can move the value up and up again. We can move the value down, and pretty simple API, right? So now let's add some security to this REST API. And then after that, we'll add our front end. I like adding security after the fact in demos, but I recommend that you add it from the get-go in your application. But I add it in demos because then it's a little easier to see the difference in behavior. So let's go ahead and add the appropriate Spring Boot starter. And then all we got to do is just restart the application. And we'll see some important differences in the way that it behaves. The first thing that we'll notice is that if you try to hit one of the endpoints, then it gives a 401. You can see it right here. You can also see it in the response header, that it wants HTTP basic. It wants some kind of authentication in order to be able to give you a response. You'll see that that's the case with any endpoint that's created by the application. Any boot endpoint, it'll do the same thing. Any gobbledygook endpoint or any third-party endpoint that Spring Security or that Spring doesn't know about, so long as it's using servlet filters, all of that will be protected as well automatically. The way that it's protected is with HTTP basic. So valid question is like, did we just lock ourselves out? The answer is no. All you have to do is Google for what is the default username and password for Spring Security. Actually, no, not at all. That would be a terrible idea, right? We all did that with, or all of our friends did that with like Tomcat years ago when we had like a 3AM production bug and we would Google for the username and password. Except for Paul, he would just ask me what it was. So let's go ahead and find out the password right here. Actually, it's with Spring Security, it's generated. And that's important because then using the Spring Security defaults, it's not possible to deploy something that uses uses the default, something that could be Googled or found out or whatever. You probably want to change this out for a real username and password. But that way, if you're deploying with the Spring Security defaults, things still work, but they're still secure. If we try to do one of these, one of them that mutates, if we try to go up or down though, we still see a problem. If you look here, you say, I still need the creds, even though we provided them. And there's a little bit more. Let's see if we can. And we see that we still are getting a 401, which may seem a little odd. And I'm going to leave the suspense on for just a minute because we'll find out why in a little bit of time. But the short answer is that Spring Security is there to help you to keep yourself from like shooting yourself in the foot. There are a number of security features here that are on by default, and it's up to you to turn them off. That's a much more secure way to release software than to say, hey, we've got all the security features off. Make sure that you turn them on. So there's some protection here that we'll talk about in a little bit that becomes important specifically when we're talking about our topic today, when we have some JavaScript in the browser that's trying to contact a REST API through like an AJAX, through XHR or something like that. So let's go ahead and do one more thing before we go, though, over to the app. Let's change out the user so we don't have to check we don't have to like screen scrape for the password each time. What we'll do is, let's see, I think I have a little shortcut here just to move us along. So what I can do with Spring Security is I can specify users using the user detail service. For folks that have used Spring Security before, this is a really familiar thing. This is just how you, this is just the Spring Security component that we can expose in Spring. And in this case, I'm just going to specify it in memory. Usually this is like a connection to a database or looking up tables or in what we'll learn later on is we'll change this REST API to not even keep track of users themselves. It won't be its own identity provider. We'll delegate that over to an authorization server. But now with those changes, we should be able to hit the endpoint with Bob, and Bob gave me every assurity that this most definitely, assuredly, he promises is not his real password. So I can go ahead and use it.
Everyone knows my password's 12345. Dang it.
There you go. I should not have said that. All right, great. So now we can hit the endpoint just fine again, right?
Now I got to change the password of my luggage.
So the posts still aren't going to work. That's not an authentication thing. It's a security defense mechanism. So even if I change this out to like try and post now that I've specified a real user, it would still break. So let's move towards fixing it, but by adding a front end so we can kind of play around with it a little bit and see how it behaves. So let's jump ahead a little bit. We added a REST API. We added a user. So let's go ahead and add our single page application. Some of the JavaScript is already going to be here for us. I wrote it beforehand since it's not precisely our topic today, but like how to call AJAX from JavaScript. But just to give you a quick summary, obviously not very much JavaScript. We just have a few AJAX calls. One of them is bootstrapped when the page is loaded. And then when AJAX calls come back, then it enables the buttons. So really pretty simple. There's probably frameworks out there that would make this like even less code or even simpler to do. But it's small enough to just use something like jQuery and it'll still illustrate the security principles. So let's run this application too. So we have the sentiment application. It's working. Or I think I already restarted that one. And then let's go on and head over to the app. And it works perfectly, as you can see. Actually, no, it doesn't. Let's see if we can figure out what the problem is. Now, if you've worked with SPAs or browser-based applications before that are talking to REST APIs, then you might have been able to predict this, which is that these are on two different domains. And oftentimes in deployment, they're on different domains as well. Even if you have all of your REST APIs behind an API gateway, that API gateway might be on a different host than the client applications. And so this can easily come up in any application, even though it comes up definitely right now because we just have two apps that are on two different ports. Anytime the domains are different, if you want to have one application call another from the browser, there needs to be a stated agreement between the two of them that that's allowed, and that stated agreement is called CORS, or cross-origin resource sharing. one principle that you'll find comes up quite often in security is allow listing. It's being declarative and saying this is not allowed unless I say so, and so that's the principle at play right now. So here in the sentiment application, that's the one that needs to say, yes, it's okay for other people to talk to me. And so we'll go ahead and publish a security filter chain to configure that, to configure Spring Security for cores. And I'm super stoked about this feature. If anybody has used Spring Security for 5 minutes or longer, you know that it's usually been the case that you've had to extend Web Security Configure Adapter. And that's definitely not as fluid as just publishing a bean. So in 5.4, this support was added. So now you can go ahead and publish your filter chain just as a bean like this. And I think it's super beautiful. So the other things that we need to add here are good practices and important to remember. So we've turned on cores just by calling the cores method, but we also want to say that any request requires authentication. This bean is created by default by Spring Boot, and it by default says we're going to defend all the endpoints. And since we're replacing that bean, we'll just re-specify the things that Spring Boot was originally specifying for us before we overrode it with this method. Okay, so we've turned on cores for Spring Security. It's ready to go. And the next step is to say what kinds of things are allowed. So cores is turned on right now, but Spring Security is ready for cores, but there's nothing stating which domains can talk to me, which endpoints are okay. And so that's what we'll do here. I'll say that we can call that resource endpoint, and it's okay if localhost calls me. That's just fine. Since we're going to change this a couple times, I'm going to go ahead and tell it not to cache, so that while we're changing it, we don't get kind of like just some unexpected browser behavior. And let's go ahead and restart. So here we've published a bean with Webmbc to say, like, here's what's allowed with cores. And with Spring Security, we've just told Spring Security to expect cores handshakes. So I'm going to leave this up, even though it's kind of big. We'll just go ahead and refresh it and see what happens. Okay, great. We're on to our next error. Perfect. We had a cores error, and now the communication is allowed. Like, we're able to talk to 8180, but it says you're not authenticated, which, of course, that makes a lot of sense because nobody's handing us any credentials. As was talked about earlier, there are a few different ways that we could possibly provide creds. The way that we're going to do it right now is very simple to get us started. And then let's see. Let's go ahead and just real quick see if this will get this attached correctly. Looks like IntelliJ decided that this shouldn't be a Java application, but that's pretty easy to fix. That's fine. We don't need it for a bit. And then once we restart, I think it'll be just fine. So let's hop over to the JavaScript and try and fix the 401. So we need a way to know who the user is. And a simple way is to use HTTP basic. That's what the REST API is requiring by default. And so maybe we can obtain those credentials from the end user. We can do that using the browser. The browser can manage creds for us. And we might not use this very often, but I want to use it today to make clear a point about what kind of defense mechanisms are necessary when you have a REST API. I want to show you something that is possible, and because it's possible, we want to have security features on by default so that we correctly think about it before we shut them off or something like that. So we can use XHR, for example, inside JavaScript to say, hey, anything browser that you have that you're managing for 8180, our REST API, go ahead and send that as part of the AJAX request as well. So any HTTP only cookies, any HTTP basic credentials, you can go ahead and do either send all of that over, and that would just be great. So if we do that, then what the browser will do is it will ask us for creds. We can provide them, and then that will be sent along by this JavaScript into across the wire over to the REST API. So let's check it out. Great. One more change that we need to make. So, and I do this step by step here so you can kind of see like each thing that we're doing and what the differences are. So now it's saying, hey, I'm trying to pass credentials, but that's not going to work because you need to allow it. With cores, we have to state everything that we're going to do. And so we'll go ahead and say, yes, on my end, it's okay too. So in the JavaScript, we said, please send the creds. And over here on the REST API side, we said, yes, we'll go ahead and accept credentials from the browser. You can imagine how this could possibly be insecure. And indeed, there's a little warning inside of here that if you do this, then keep in mind that means that on every AJAX request from this domain, the session cookies, HTTP basic credentials, they'll all be passed over to this REST API each and every time. Okay, cool. So now let's see if I can make this a little bit smaller. Hopefully folks can still see that. Go ahead and ping me if that turns out to be too small. All right, so now we start seeing a little bit more of the application, right? We went ahead and queried for Bob's value and it came back as 0. And so like, let's go ahead and move it up. And oh, it doesn't work, right? What's going on? Because now we're handing the credentials over and we're not doing any authorization yet. So really, shouldn't all of these endpoints have the same level of security? And the answer actually is no, because up and down, those are endpoints that can change values, whereas this can only read values. When if you have an endpoint, if you have endpoints that can mutate, if you have posts, puts, or deletes, and they can be addressed from the browser, then you need extra defense. And that extra defense is called Csurf. It's possible, for example, for other websites to call these endpoints and get those endpoints to hand up their credentials, even without cores, because since these are posts, I can just like create a form post on like an evil website and tell it to, and the browser will happily send up anything that the browser is managing for this host, including HTTP basic credentials. So sometimes it's a mistake that folks make that, oh, it's a REST API, I don't need Csurf. Because it's not like a web application, but you do if you're using HTTP basic because the browser will hand those creds up as well. So let's go ahead and add some defense for that. Now it's on by default. That's why we're getting the 403s, and it might be really tempting to turn it off. In fact, that's a really common response I hear in like Stack Overflow. I see Stack Overflow answers that says, oh, to get that to work, just disable Csurf and then you're fine. But we really should leave it on. And in fact, during the presentation, you'll never see me turn it off. You'll never see me use Csurf disable because typically that's typically not the right move. There's usually a better approach that you can do. So what we're going to do is we're going to set up cores for Csurf. Csurf is transmitted via a header. And so I'll go ahead and say I allow this header to come from localhost 8080. And I'm also going to expose that header because the REST API, I'm going to hand this back. And the Csurf token is a randomly generated state that the server holds on to that it's going to send down to the client and the client will send it back. And that randomness is going to give the REST API confidence that you're the only one that would know this randomly generated value. And so that's why I can go ahead and believe your request to change the application. We also need to send it down as a header. By default, it just leaves it in the HTTP servlet request as an attribute. So we'll go ahead and create just a quick class. We can use Spring's header advice to do this. fairly easily, or excuse me, header advice, controller advice. Specify that we are going to be adding to the model, and just return the Csurf token. There is a gotcha with the Csurf token, by the way. In Spring Security, there's two of them. There's one for servlets and one for Webflux. So, so make sure to keep an eye on that as you're using this class. And with Spring Security working together with Spring MVC, you can go ahead and create this method, and they'll get these values for you from the request or from wherever they need to be obtained. Then we can set the appropriate header. So now we're ready to go on this side. We've said cores, yes, the token is allowed. And we're going to go ahead and write the token as a header into the response. On the front end, we need to do the same kind of thing. We need to get it, and we need to send it back, because it's part of a continuous conversation between the REST API and the client. So first things first, I'll go ahead, and I've got an AJAX success method already. So I'm not gonna put it here just to make it a little easier to read, but we'll go ahead and anticipate that I've got a method down here, which I'll create. And I'll just write that now so I don't forget to add it. So if we have some kind of method that whenever an AJAX succeeds, we'll go ahead and inspect the XHR response and see whether or not there's some Csurf value inside of it. I can go ahead and just have some simple configuration here that says what the header is, what the header value is, excuse me, what the header name is. And then whenever an AJAX request comes back, we'll call this method and we'll save in memory the Csurf token so we can use it later on. And then we need to send it back on each AJAX request. If this sounds like a lot of boilerplate, there's frameworks that will have some support for this. Angular has support for it, by the way, so it can do it for you. And so I definitely advocate taking a look at those kinds of things. Today, we're doing it raw, so you can kind of see what's involved with each one of them. So if there's a Csurf token in memory, then let's go ahead and add it to the request. Great. So now we'll go ahead and restart our applications. And we should have a better behaving app at this point. Oh, there we go. All right, great. So now we're good. Now we can go up and down because there's that Csurf token that's being handed back and forth between the REST API and the application. Now we can get rid of let me say that differently. It may seem troublesome, like when you're thinking about it, saying, "But I have like dozens of REST APIs, or I have lots of things that I'm communicating with. Does each one of them need to like hold on to a Csurf token, and this needs to like hand back all of them, and like how does that all work?" We can simplify what we're doing here by thinking about authentication in a slightly different way. There are a few, aside from that, there are a few other limitations with what we're doing here. For example, I already mentioned the fact that the HTTP basic credentials, they're stored with the browser. And I think that you and I would both be pretty squeamish to know that a website, the way that we're authenticating, like your username and password are just hanging out in your browser. Also, there's like performance implications because you have to hash a password, and if it's passed over on every request, then that's not very performant because you're taking a half a second to hash a password in order to mitigate brute force attacks. And there's no real difference between who you are and what you can do, because as soon as you're authenticated, as soon as the client has your creds, the client application can do whatever you could do. And maybe you didn't want to give the client that much power. So there are, with those limitations of HTTP basic in mind, we want to try to evolve our application into something a little bit more, not only more flexible and more performant in authentication and authorization circumstances, but in the end more secure. We'd prefer the browser not be holding on to these secure pieces of information. It's really hard to keep secrets in browsers, as we've learned over the many, many years of trying to do it. And so let's, instead of using HTTP basic, let's go ahead and delegate to a server that specializes in this kind of thing, and then allow it to authenticate the user in whatever way it deems worthy, whether that's WebAuth or a username and password or anything like that, and then award the client application with some kind of token that allows it to communicate with REST APIs instead. Excuse me, communicate with REST APIs that way instead of using the user's credentials. All right, so let's bump up. Use my mega mouse here on the corner of my Mac. Let's see, check out. Great. All right, this is our last application. We're not going to do very much with it because usually an authorization server is just something that enterprises typically don't build. They usually use like some kind of managed service to handle their authentication. But I have it here today because it's convenient for demoing. And it's also fun to mention to everybody that there's an experimental project going on right now with Spring Security. If you go check out Spring Projects Experimental, you'll see one called the Spring Authorization Server. And that's this right here. And so I'll be using that today. If you're interested in something like that, it's very new in the development process. It's still in the V0 phase. I think they did their second V0 release, so it's on 0.02, and all kinds of things are being added by the community right now. If it's something of interest, then that's a great place where you can contribute your efforts. So I'll go ahead and run that. And then let's change our applications to use that instead to authenticate the user. First things first, the REST API is not going to use HTTP basic anymore, just like we talked about. Instead, it's going to use OAuth. And more generally, sometimes OAuth can seem kind of daunting. And so you can think of this a little bit more basically as bare authentication, where basic authentication is using that authorization header to hand the user's creds. Instead, we're just using that same authorization header to hand a token that the authorization server gave us after they authenticated the user. So in order to achieve that, I need to configure my server, my REST API, to know where the authorization server is. In this case, I can say that it's at 8280, and the endpoint that the resource server is going to need is to know how it's going to verify the job that comes in. One way is with Jukes, and so it's a little bit outside of our topic today because we're talking about the front end, but that's what I'll do here because it's pretty convenient and nice and quick. And then we'll lastly come over here and say we're not using HTTP basic anymore. Instead, we're going to use resource server. And I'll also say that we are we're using, oops, we'll put it over here. We're using JOT-based tokens. There are other options in here, and you can go ahead and play with those. There's opaque token, and there's a way for you to customize and negotiate it more in like a custom setting. But the difference here is that we're going to move from a browser-managed authentication mechanism to one that's managed by this separate service, the authorization server. Because of that, note that the reason that we needed to add Csurf to our REST API was because our REST API was accepting an authentication mechanism that could be managed by the browser itself. Because this one isn't managed by the browser doesn't know bearer authentication. It doesn't know about your token itself. Your JavaScript might, but the browser itself isn't holding on to that. Then that means that we don't need Csurf protection here in this case. So we can turn all of this header stuff with cores off and exchange it for the authorization header directly. So we'll hand the authorization header directly in our JavaScript here in just a minute. Great. So by changing our authentication mechanism, we were able to change the security profile of our app just a little bit and change what front ends need to be able to do to communicate with it safely. So we'll restart that application and then we'll come over here. And the next thing that we need to do is, you saw this happen with Csurf, and now you're going to see it again with these tokens. We need some kind of way to get just like we needed a way to get the Csurf token and be able to hand it back, we need a way to get this access token and hand it back. And the way we do that is by talking with this authorization server and asking the authorization server for the token. I'm going to show you one way to do it, and just kind of paying attention to the time here, we might have time to show a second way, and if we don't, then I'll just refer to it so you can research it yourself. But the first way that I'm going to show is a simple but still not super secure way. It's better than what we have, but we can do much better than what I'll be showing here. But it's nice, and it's a nice comprehensive step from where we were earlier. So there's an endpoint on most authorization servers called authorize. Sometimes authorization servers will customize that, but it's typically called authorize. And if I hand it a few details, like I would like an access token, and I'll tell you who I am. I am this client right here. Then, once you have authenticated the user, would you please give me a token? That's what that request says. So we can go ahead and say, redirect the browser to the authorization server if, or when necessary. And then on the way back, there's going to be some parameters for us to look at, because the authorization server will redirect back to our application once it's done all the authentication. So we can ask a question like, if we were given an access token, then go ahead and save it. So we'll go ahead and call that method. Oops. Which will get the query params from the URL, hand those to our token method, and then if there's an access token, then we'll just save it. Now that we have it, that's similar to this guy right here, right? Now that we've saved it in memory, we can go ahead and pass it back, or we can go ahead and pass it to our REST APIs by doing the same thing that we did earlier with Csurf. And then all we need is something to bootstrap the process, because we have this authorize method. This authorize method says, when we need an authorization, please redirect to the authorization server to go get it. It'll hand us back an access token, and then after that, we can go ahead and call our stuff. So we can do something like that by, again, intercepting our AJAX requests and saying, hey, in the event that we are getting back like a 401, or we get back a 403, then go ahead and authorize the application. So just a quick review. when the application first comes up, it's going to check, not going to find anything because we're just going to logos 8080. Then it'll try reading a value. It will get a 401 or a 403 back because this application isn't authorized, doesn't have a token. So we'll try and authorize, which will redirect to the authorization server. Authorization server will authenticate, send it back. We'll look for the access token, save it, we'll call read again, and read will succeed at that point. All right, and then did we start up the, yeah, I think we did. If we didn't, we'll find out pretty quickly. Let's go ahead and just check real quick. See my trusty Mega Mouse. Right. I just don't know how to type. There we go. We put it in a different struct right here. Okay, great. So now let's see. Oh, sorry, there's one more thing that we got to remove. Lots of stuff to remember when you're changing from like one fundamentally different authentication mechanism to another. So now, like we said, you'll notice that we removed that allow credentials on the one side. So we'll remove it over here too, because we're not sending back HTTP creds. We're not sending back browser managed credentials anymore. Now we're sending them on our own right here with this header here. We're doing it manually in our JavaScript using data that only we have, that the browser doesn't have itself. Okay, cool. So now we're logged in, or now we're redirected over to the authorization server, and we get logged in and we're good again. The only big difference here, or the major difference, is that we asked somebody else to do the authentication. We've removed the liability from the REST API and our client application to figure out who the user is. We've delegated that onto an authorization server, and now our application is just a little bit more just a little bit more secure than it was before, because we're no longer holding on to the user's creds. But like there's this icky thing right here, right? So if you put your security hat on, you can see why this would be mega, mega bad. To have an access token inside the browser history, to have it inside of our request logs, and anywhere else that kind of stuff promulgates through and touches inside of our infrastructure. That's not cool, because this is a secure piece of information. It's something that this client application can use in order to address REST APIs inside of our infrastructure. Because of that, this guy right here, I didn't tell you at first, but this right here is actually deprecated in OAuth 2.1. So in 2.0, it's there, but it's deprecated in OAuth 2.1 because it has different ramifications like this. It's really convenient. It's really easy because we can redirect and then it just redirects back to us with the token. We need something more secure inside of a browser than this. And fortunately, browsers are much more powerful than they were back when the spec was first created. So we have a few more options than we did. For example, like cores, with the introduction of cores in the last 7 or 8 years, I'm not sure exactly when it came out, that has made other kinds of things possible, like what I'll show you next. So, oops, let me just scroll down a little bit so I can see more of the thing. So what I'm going to do is I'm going to show and explain very lightly, but if there are questions afterwards, I'm happy to explain it more. A different authentication mechanism for getting a token that you can do in the front end that is much closer to being secure. It still has some issues, and I want to point them out and finally point out a different way that we can architect this application. That's in my opinion better than this one, but this is a nice happy medium depending on what kind of architectural constraints you have. So there's a whole lot of code here. A lot of it came from Aaron Parecki from Okta. So thank you very much for his blog post that showed some of the lower level JavaScript stuff that I wasn't familiar with. But essentially it's the same kind of thing as before. We need to go to an authorization server to authorize, and we want it to give us back a token. The difference is that there's an additional hop in between here. The thing that gets redirected back from the authorization server is a lower security item. It's called a code. The reason it's lower security is because REST APIs don't recognize it. They won't give you any access based on it. You have to turn the code in for an access token. And the way you turn the code in is not via a redirect, where it ends up in the browser history and everything. It's instead via another AJAX call. And then this AJAX call is secured by two things. First, we secure the whole handshake with a random state. You remember that we talked about Csurf. And with Csurf, the server, the REST API, generated something random and asked the client to send it back to the server on each request. And we're going to do the same thing here. The client is going to generate some random state, send that over to with its request to the authorization server. Authorization server will redirect and send that back. And we'll check and make sure it's still the same thing. State is a very common thing in security because oftentimes, especially in the browser, we can't keep secrets very well. And so we use randomized state instead of as one alternative to secrets. Another example of that is what we're going to use in order to authenticate with the token endpoint. We're going to generate a random password. We'll hash it, hand that hashed password to the authorization server. And then when we do the token request, we'll give it the unhashed version for the authorization server to check. If that all sounds really complicated, it is pretty complicated. But such is the case when we are trying to do these kinds of things in a very insecure place like the browser. So I'll go ahead and refer to that piece of code here, and then we'll refer to it here as well. Now, by the way, there are certainly, again, frameworks that can do the heavy lifting on Pixie for you. But I show you the full thing here so that you have an idea of the kind of work that your browser is doing in order to keep things secure. So now it's a promise because it has another AJAX call, right? So we'll have to go ahead and pause, wait for that token to come back. And once it does come back, then we can just save it like we did before. And then we can call our read method once again. Okay, cool beans. Everything else should remain the same. Just doing a quick check here. We'll go ahead and restart our application. And see if you can identify the one last thing that we need to do for all this to work. We are calling for a resource cross-domain. So we did that earlier, right, when we were first talking to our REST API to get that sentiment value. And now we're doing it to get that access token from the authorization server. So we need to turn on cores on the authorization server as well, now that we're doing Pixie in the browser. So let's go ahead and do that. First thing we'll do is create that security filter chain that you saw me do earlier with the REST API. This time we'll do it here in the authorization server. And then we'll turn it on just like we did before. But this time, again, it's for the authorization server. So we have a specific endpoint that we want to allow the browser to hit. And it's the token endpoint. So right now, as it stands, the 8080 application is the only one that can, in the browser, talk to this token endpoint. Now, in this case, the authorization server doesn't change because it's just a way to obtain the token. The token from the perspective of the REST API is the same as it was before. However, now that we have authentication and we actually have more than one user, I don't think I said that. I created a few here of my 3 favorite people, Bob, Tiffany, and Paul. So we can log in as each one of them now. But let's go ahead and change this so it's not just always Bob.
I feel so special.
I'm glad you do. I did that just for you, Tiffany. we can get the currently authenticated user in Spring Security by asking for it in a Spring MVC managed method. So let's go ahead and take this and we'll replace all of these guys. And now what will happen is whoever's logged in, right, whatever their name is, we'll go ahead and get that from the correct map. Okay, so hopefully that all worked out. Again, that was a lot of code to change. A lot of it was because Pixie is more complicated and it's complex trying to do secure things inside an insecure environment like the browser, or a less secure environment like the browser. So let's go ahead and try it out. Great. So now we redirect and it asks us a couple things that I forgot to show you in context, but now we're asking for the scopes, which you can see here. It just was a change in the URL that I was sending over. I didn't point that out, my apologies. But we'll go ahead and say that it's consented and now we're great, right? Just another way to obtain the token. And now the REST API is just fine once again. We can log in as somebody else now. So let's log in as Tiffany, just because she seemed so touched by it. And then we can go ahead and see her value now, right? And that's it. Okay, so what have we done so far? What have we achieved? Now, instead of using HTTP Basic and having the browser manage those credentials, we're managing the credentials ourselves, and we're doing it in a more secure way because the access token isn't inside of the browser history and it's not inside of our logs and everything like that. But there's something that still kind of needles at me. There are lots of people that use Pixie these days inside of the browser. It's the de facto standard if you're going to be using OAuth in the browser to get a token that you can use to authorize yourself to REST APIs. Authorization code with Pixie is the gold standard. But there's something that's not great about it still, and that is that this value is still in the browser. Now, it's not managed by the browser, so that's way better, but it's here in the browser. And if your website is vulnerable to cross-site scripting, then it's pretty easy to write a very general script that can override this set request header and obtain the access token. So all of that work was really helpful, but there are still places where we're vulnerable. And what I'd love to do is just not have the token in the browser at all. I'd love to have the server take care of my data and take care of a little bit of my security. Oftentimes we look at our backends as places that just hold on to data these days, but I invite you to consider that security is something that backends are a lot better at. So what I'm going to try to do is remove any notion of the token, of the access token from the browser. What we'll do here is we're going to change this application to have what's called a backend for front end. It's called the BFF pattern if you want to go Google it, or the backend for front end pattern. And what that means is that we are not going to take care of authentication at all in here. So if we realize that we need to reauthorize, get new authorization to talk to our REST APIs, then we'll just reload the page and let the backend take care of it. If we can do that, then we can do this. We don't have to negotiate the token because we don't need to keep track of it anymore. We don't need this humongous script, and we don't need to refer to it. Okay, cool. So how are we going to do it? Well, there are two things that we're going to do, and this is the point in the demo where I'm hoping that I can figure out how to quickly fix this, why it's not loading the Java application. Let's actually just try that right now. I'll go ahead and remove the module and add it back in, and I think it'll be fine. Okay. And then here, we'll go ahead and just add her back in. We'll see how that goes. Okay. Let's see, there's something still kind of funny with it. Let's go ahead and try one more thing. Oops, that's not what I meant. Let's see if it's telling us why. It's no problem. Let's just try one more thing. And if that doesn't work, then we'll talk about the change.
We can just pretend it worked. We're pretty good.
Yeah. You guys are really imaginative. Okay, cool. All right, let's go ahead and this will only take a moment. Shall we throw caution to the wind? Let's do it.
Oh, there was a few folks in chat trying to give you hints. One was right-click on top of package and mark this as source code. And
yeah, I could do it manually. That's a good point.
Also, check in the project structure if there's anything wrong with the modules mapping.
Sure. Okay, we'll take that. We'll take a look at that.
Otherwise, you can always try throwing your laptop into a full bathtub
and see if that works. Yeah. Okay, we'll go ahead and get it from existing sources. Let's see. Let's see. That's not what I wanted. Isn't there a new module from sources? Oh, there it is. Let's go ahead and try this. Okay, cool. Well, as sometimes happens in demos, I cannot explain why this happened, but no problem. Great. So now that it's a Java app, we can go ahead and do a couple Java-esque things inside of our application. And what I want to point out specifically is that we're still going to be using these static front-end resources. We're not going to be doing any dynamic HTML. We're not going to be introducing any of that. These could still be like served from some remote place, from a CDN, and things would still work. But we're going to ask the backend to take care of the authentication for us. Check out what happens when we decide to give the backend the job that it's good at. So it's easier to keep secrets. It's easy to be secretive on the backend. So we're going to say, backend, I want you to be an OAuth client. And also, because we're going to follow the backend for front-end pattern, we're going to turn this also into a gateway server. And we'll see why in just a minute. So first things first, let's turn it into a client. To turn it into a client in Spring Security, there are a few settings that we do. And a number of these can be automatically learned by the application, but I show them here just so that you can kind of be familiar with or see some see some association with what we've seen already. Remember that authorize URL that we were redirecting to, the token URL that we use to hit up the token, the juke URL to verify JOTs, right? So a lot of these things can be inferred from configuration, so they don't have to be specified. But essentially, we're turning this application. We're going to keep it as an OAuth 2 client like it's been, but we're going to let the backend take care of it. Second, we're going to add a simple routing config. This routing config is something that we get from Spring Cloud Gateway. And what it allows us to do, let's see. Oh, did I not add the thing? Oh, right. Okay. What it allows us to do is define a way to forward requests from one application to another. And so we can say, hey, anytime you address me, my application, I want you to actually go down to this REST API, at least for this directory. What that means is our JavaScript will change in one other way, right here. And we're going to address our application directly. Because of that, there's there's always trade-offs, right? So the trade-off here is, so first of all, we're going to allow our application to take care of the security. And what we've done is, because we're going to address our application directly, it's going to hold onto the token for us. It'll hold it in a database. It'll hold it in the session. And our browser doesn't have to hold on to it anymore. We don't have to try to hold on to that secret. One of the trade-offs is, though, that now we're addressing an application that's not a REST API, that's not using bearer token auth, right? And so we need to reintroduce our Csurf defense. So remember that header that we had? But now it's with this application. It's a reactive application because we're using Spring Cloud Gateway. Spring Cloud Gateway is a reactive application. And so we'll go ahead and write it as a header in the reactive way. And anybody who hasn't played with reactive, it is a little bit of a surprise how the API is a little bit more involved when we're trying to defer actions and handle things via publishing and subscribing. But what we can do is we can do the same thing that we did before. Once we have it available to us, we can get the header name, just as before. And we can get the value. And then that'll be written on the response as well. So let's restart our application one more time. Over here on the other two applications, we're in for a treat because we don't need cores anymore. There's no front end that's talking to the authorization server to get the token. It's all being happening by the back end. So we don't need to have this specialized cores configuration. Also, we have our front end here, or excuse me, our REST API. And our REST API isn't being addressed by the browser either. So we can go ahead and we probably could have deleted the Csurf thing a while back, but we don't need that anymore. It's only being talked to by a backend, so we don't need cores anymore. We don't need to turn this on at all. We also don't have users anymore because those are being taken care of by the authorization server. And actually, there's nothing custom in here anymore. Now we're using all of Spring Security's defaults, so we can get rid of this too. So this is what REST APIs ought to look like, right? Nice and simple, and all they have to worry about is getting a token from our front end. All right, so let's go ahead and we'll just let's see. Can I do this quick? Let's see if it works. Okay. See, of course, since I deleted all of this, now I need to Okay. So let's see how well this works. We'll go ahead and we'll log in again. Log in as Paul. And
now I feel special.
Now you feel special. Isn't it great? Oh, we did forget one little thing. And that is because we're having Spring Security take care of it now. Now we have a different redirect URI. And it's just whatever the default redirect URI is for Spring Security. But this is these configurations that you see here on the authorization server side would actually probably be done via some kind of UI, like you sign up for Okta or something and you specify all this information. It wouldn't actually be here in the code usually, unless you're developing your own authorization server, which isn't terribly common. Okay, so Paul asks, like, do you consent? And he says, well, yes, I do. And now, one more time. Oops, let's see. Do we have a little bug? We might have a little bug. What did it say?
Sorry, Paul, no love for you.
No love for you. You can't be happier or sadder. Let's see, what did it say?
Denied.
It says denied. It says that you're not authorized. Let's see if we can find out why. Oh, is it because, maybe it's because I didn't do the thing correctly. Hang on, let's double check that code. So that appears to be correct. Let's just see if that response is coming back on the network. Here, we'll make this a little bit bigger so I can go faster for everybody. Just have to wait for, there we go. If we go get this one, response headers, it is bringing the token back. Oh, maybe it's, that's interesting. It looks like there's one of these that maybe didn't get fully restarted because I don't know if you saw that. There's two Csurf tokens, one from the REST API and one from the app. So let's just restart. We'll try it again. Paul, you're giving me so many problems. Right here at the end, too.
That's just who I am.
Okay. Oh no, what's going on? We'll check one more time, see what's going on. Of course, in demos, you plan for every eventuality, and the only time you see the error that you do is in your demo, right? So we'll just do one more quick check and see if there's something that is readily apparent. And if not, I don't want to waste everybody's time. We'll go ahead and wrap up. But let's see. And if we can get this done, then I want to see if we have time to just explain one last idea. So that looks okay. My guess would have been that this fellow is, for some reason, sending off a token back as the header. We don't have any configuration left. We've restarted everything. And I don't see any issues here. That's really curious. I'm so sorry, everybody. I will take a look at that. Of course, oh, you know what? I do have an idea. We could just like update to the latest, right? And see, because it's probably just a bug in what I've written. And so let's come over here. And we'll go ahead and just update to the latest. Do a force checkout. So let's try that. Go to restart the world. Somehow it still feels like it's something I've done wrong in IntelliJ because all the code seems correct. but this will get us
definitely
faster.
IntelliJ's fault. Your code is amazing.
I have never actually coded an error before. This is you guys are really in for a treat. This is like the first time I've ever made a mistake, and you guys were here to see it. Let's see.
And it was live on the internet, and it's here for
I know, right? It's amazing. Okay, cool. All right, let's go ahead and try one last time. And if this doesn't work, then I don't have any other ideas. Oh no, there's something weird. What the heck? All right, no problem. It's IntelliJ's fault. You know what? No, I just like now I'm getting into debug mode now, and I just can't. I can't do that to you guys. That's too boring to watch. Okay, cool. So, what we achieved, at least with reading the value, is we were able to get the token back through through our backend for front end. And all our backend for front end is just this router right here. Right? That is, hey, when you talk to me, I'm going to route down to the REST API. And because this application does a better job at holding on to the token than our browser does, then we have the wonderful benefit of not having we didn't delete that, but not having the token in here at all, because we're not taking it. We're not negotiating it here, and we're not handing it back. We're not handing it, and because of that, we are not handing it back. This is a more secure approach because we don't have that super secret access token inside of the browser anywhere. There is one other alternative that folks have approached me with before, and that's having an HTTP only cookie. It's a common question. Can I store the access token in a HTTP only cookie? And technically that would work. But what I invite people to remember is if you can pass it up via cookie, then now your REST APIs you have to reintroduce all that Csurf defense again that we had at the beginning. And second, if you can use a cookie, if that's possible, then maybe you don't need the complexity of OAuth, because the reason you have OAuth is to be able to securely hand this stuff around across different domains. So if your authorization server and your REST resource servers are all on the same domain, maybe your authorization server writes an HTTP only cookie, and then your REST APIs just read that instead of some of this complex like handing off stuff. Because of this final bug, I didn't have a chance to show you, but I would encourage you to take a look at the last commit inside of this repo. Because another common question that I get about front ends and how to do things securely is, what do I do about scopes? What if my front end needs to know the scopes? And the answer that I give these days is, first of all, if your front end needs to know those aren't super secret pieces of information. They're certainly obtainable in a lot of different ways by those nefarious people who might want to know it. However, you can prevent your front end from having to duplicate a lot of authorization logic by thinking about your REST API as a source of hypermedia. And if you've used Helios before, then consider having your REST API return, in addition to its resource, in addition to its the values that resource is protecting, the things that can be done with that resource. You can use a module called Spring Helios that will add links to your resources as you return them. And Spring Security is looking into integrating with Spring Helios and adding inspection of its configurations to decide whether or not those endpoints would actually succeed, if they would be allowed given that bearer token or whatever. And so doing that, you can allow the REST API to inform you via the links that come back as to what's going to be permitted and what's not. And it can create a lot simpler of an application over here. To just point that out, you can see it in this commit right here. It's the last one. I encourage you to take a look at it and give me feedback. It allows you to have very complex authorization rules on the REST API side instead of like having to duplicate those or write them in the front end. Worst case scenario being that you're duplicating and trying to maintain both of them. If you can allow the back end to just make those decisions and return as part of the resource the actions that can be performed with that resource, then you can continue to further simplify your front end from a security perspective. And that's it. Sorry, we had a little bug at the end, but
there were a bunch
check
of
it out.
Comments in the channel that may or may not be useful. So there was, without authentication on API part, should we prevent direct network access? There's a 403 arrow to CSRF. And there's, seeing as the default config is being used, shouldn't you do a CSRF.disabled in the API code, considering you're using the CSRF from the backend from front end?
Okay, cool. So lots of questions. The first question, network security. Yeah, so layers of security are fundamentally important. So I advise folks to not rely on application security, nor to rely on network security alone. If you rely on network security alone, then there's like this gate 21 in your application that as soon as you pass that gate, then now you can like command the whole API. And so while that may be acceptable in some situations as you analyze and do your own threat modeling, it's important to remember that relying only on network security does mean that if someone can get there, then they can then they have free reign over the app. And I like network security just as a further defense mechanism. If I know my app is ready for it and is secure and is going to be just fine, but then I have that extra layer of network security, then it's just an extra layer of defense. One of the most common principles that you hear app security people talk about, or even just security people in general, is think about security in layers, because it's hard to be secure. It's hard to say something is secure, and if one layer gets penetrated and there's another one, it simply helps you during incident response, and it helps mitigate the attack, be it as sophisticated as it might be. With regard to
quick, while we're still on that subject, before we move to the next one, I've been thinking about this a bit lately, and that is our application security is starting to leak into our network through things like Istio and the way it does mutual TLS. Do we run the risk of kind of forgetting about app security, thinking that our network is doing it?
Yeah, I think that's
if we are using something like Istio to do the mutual TLS, is it still on us at the app level to still be validating and verifying the tokens or whatever that it's coming up with?
Yeah, that's a really good question, and it's one that I've heard a number of people ask, and so I think it's definitely something that is worth talking about. So, mutual TLS establishes authenticity between two like programmatic entities, right? Like two services or what have you. And so one of the things that I invite people to consider is, if someone can address it, what can they do? And if, like, say I have the whole handshake, and because I'm using MTLS, then I can go ahead and command the API. Are you okay with me doing anything that I want at that point? And if the answer is no, then there are still places where we need to consider application security, because MTLS is there to provide confidentiality, provide integrity, and provide authenticity, but not for the end user. It's to provide authenticity for like the API gateway that's talking down to the REST API, or whatever it is. So I think that's one thing. But yeah, I would agree that that the more sophisticated any one of them gets, the easier it is for us to say, oh well, if they get past that, then we're totally hosed, which really is usually just kind of like a cop-out statement for, like, we have deadlines and we don't have time to consider all of the things that might happen. That's kind of my take. What do you think?
I'm not a security expert, so that's why
I think it's an insightful question. Yeah. But yeah, app security, authentication and authorization are definitely different things. And I don't know that MTLS could do authorization for us. And so at least we need to do that. And if you need to know who the user is, MTLS isn't going to tell you. So yeah, great comment. There's a question about, should we proactively disable Csurf? I think there's value in being declarative and saying, this is what we're doing. And so I could see the argument of stating out loud that in a REST API, hey, Csurf is disabled, just so everybody knows, that kind of thing, right? That way, if the profile of that REST API, the exposure profile of that REST API changes, like how it's being interacted with, then everybody remembers and they don't forget, oh yeah, we had Csurf turned off because we were using REST, or because we were using OAuth, but now we're not, or now we've added another authentication mechanism. So for that reason, like there are lots of applications of that principle. Like if you're using XML parsing, then there's a whole bunch of like evil features in there, and some of them are turned off by default these days, but I still like to just turn them off. Like when I'm creating an XML parser, I still just like, I turn it off for sure so that I'm declaring that I've turned it off. And so if I understood that question, I think that's a good point, and there may be value in stating explicitly that you've made the proactive decision to turn Csurf off instead of knowing that Spring Security is doing something smart for you because it knows that JOTs aren't being managed by the browser. Great question. I think I've forgotten all the other questions, Tiffany.
So there was one comment, which was the 403 with the arrow to Csurf. So I assume maybe he was asking if we were supposed to be redirecting 403.
Oh, sure. Yeah, I can talk about that. So Spring Security will give a 403 in two circumstances. It might give it in others, but basically two circumstances. One is if the Csurf token is bad, and two is if the request is unauthorized. For example, one of the things that we didn't quite get to in the demo is in Spring Security, you can specify, hey, if you have this scope, then these calls are okay. If you have this scope, then these calls are okay, that kind of thing, right? Provide some authorization rules. And so if those authorization rules aren't met, then Spring Security will also respond with a 403. Because we hadn't added any of that yet, then the 403 means that the application isn't trusting the Csurf token. Now, the reason that it's not, I believe that the problem with the application, though I'm not sure what's happening since we actually did check out from Git, and that was a working application, or that still is a working application, is because it's responding with two Csurf token headers. And I don't know if you saw that in the network. I was trying to figure out how I could be sending back two, and I'm not sure what's happening there. So I believe that's the reason that the app was broken. But a 403 in Spring Security simply means either one, the Csurf token is bad, or two, your authorization rules that you've created, your custom authorization rules aren't being met by the request. Cool.
Now,
great questions, everybody.
Telling us we only.
I know it's time to wrap up. Maybe. Oh, yeah. So, any other questions? Happy to respond to anything else.
I think that was it. The only other thing that was mentioned in there was Spencer saying that you can now do f.token relay. It's part of the Gateway DSL now.
Oh, very cool. I'll check that out. I didn't realize that. So we could do something like even, Spencer, you're saying that we could do something like even simpler than this right here. So that's cool. What this guy is doing is actually something really great. I should have mentioned it at the time. This filter is the thing that is looking up the token and renewing it if it needs to be renewed, sending it on down to the next request. So that's what makes this BFF pattern so simple to do, is working with Gateway and Spring Security together. You can securely keep the token on the back end instead of leaving it there in the browser. So thanks for reminding me of that, Spencer. And I'll check out what you just mentioned.
And also, how is the Csurf protection working with distributed applications? As in, there's multiple instances of the backends providing the token.
Yeah, for sure. Great comment. So there are a couple of things that you can do. One is you can use Spring Session, because ultimately a Csurf token is stored in ultimately Csurf token requires some form of state. Like you have to remember what the Csurf token is. You have to tie it to that user somehow. And so one route that I recommend people take a look at is using Spring Session so that those can be unified. You can also, and that makes it easy to use something like Redis or put it in a database or what have you. So that's one thing to think about. Another pattern that I see people use is an API gateway, where the API gateway is the one that is making sure that that's okay. And that way you don't have to have everybody keep track of their own token. So those are the two strategies that I found work pretty well. Good question.
Cool. I think that is about it. You can see I updated my background to
oh my gosh,
match how my authentication attempt went.
It's
Nice.
still burning. Well, yeah, thank you so much, Josh. This was a lot and great. A lot of great.
Thank you. It's a pleasure.
Yeah. Yeah, miss you out on the road too. Nice to have Spencer chiming in as well, one of our other compatriots out there on the Spring One tour. And also see Sweet Killer 9. Good looking out there. Glad to see you're still up. That's right.
Oh, I think Josh froze. I think his
Josh
laptop might have finally run out of battery.
Well, Josh, if you can hear us, thank you so much. That was amazing. If you can't hear us, then thank you so much. That was amazing. Thank you all for paying attention and asking great questions. Hopefully they were all answered. If you have any more, you can definitely go check out Josh's GitHub repo, and he will hopefully be able to, show the different answers there. Next week, let's go to next week. Who do we have next week?
While you're looking that up, I just want to do a quick shout out to the folks watching. We really appreciate it when you're nice and noisy in the channel and giving us things to talk about.
Yeah.
So thanks all for the participation.
That's right. And next week, we're creating modern static sites with Hugo and GitLab pages with Art Fuel. So that is going to be awesome. Definitely excited to hear when he pitched that to us. I was like, yes, this is going to be really cool. So next week, same time.
How to finally make my own website.
That's right. So yeah, next week, same time, 1 p.m. Pacific. Tune into Tanzu Tuesdays, twitch.tv/VMware Tanzu. But yeah, we're so happy to have you all here. This was great. Enjoy the rest of your week. Hopefully your weather stays exactly the way it's supposed to be. I don't know what that means.
Basically not like Paul's background.
Yeah, exactly. This is not how your weather should look.
No, not even close. Paul, Tiffany, always good to see you. Thank you so much. And we say goodbye.
Bye.
Bye.